Hello guys and welcome back to my channel. So in our last video tutorial on the data structure tree, we have discussed that what is a tree, how we should represent a tree into our computer memory system, and what are the different type of traversal that are possible for a particular tree. So over there in our last video, we have already covered the two basic type of traversal, that is the pre-order and the post-order traversal of a tree. And over here in this video, we will be covering the level order traversing. And do remember that the level order traversing is the most important, because with the help of this level order traversal, you can easily solve at least 70% of the problem that are given on this data structure tree. So without wasting much time, let's start with this video and let's understand that how we should implement the level order traversal for a binary tree. So let's first just briefly understand that what is actually a level order traversal. So a level order traversal is a very easy way of traversing the tree. So the level order traversal states that we need to traverse a particular binary tree level by level, which means that over here if we consider first element, that is element 1, as our root of the element, then this element is at level 0, followed by the next two elements, that is its children, which is nothing but 2 and 3 at level 1, followed by the children of the level 1, that is 4, 5, 6, 7 in the level 2. And in this way we need to traverse each level at a time, and we need to print out all the value of the nodes we have over here. So the final output of this level order traversal will be, for the first instance it will be 1, followed by 2 and 3, and there it will be 4, 5, 6 and 7. And in this way, if there exists any other nodes at the end of this level, we also need to traverse it accordingly. So this is basically a very simple and the straightforward problem statement. So frankly telling, this is not a problem statement, because none of the company will directly ask you to do a level order traversing of a tree. But while solving any problem regarding the data structure tree, you have to implement this level order traversing to get the solution of the desired question. So for this traversal, we will be using an auxiliary data structure that is called queue. So if you just look into this program, this is nothing but a breadth first traversal of a tree, because over here we are going one level at a time, which is nothing but the breadth first traversal for tree or a graph. And as you know, whenever we are doing a breadth first traversal on any complex data structure, we take the help of an auxiliary data structure, and that is queue. So let's see how we will be solving this program over here. So the first thing that we will be doing over here, let's take an example that we have an empty queue over here. And for our first iteration, we will be pushing this node, that is the root of the element, within our data structure queue. So let's put this node 1 over here. And since this is the only node at our 0th level, what we will do, we will stop our iteration over here, which means that on our first iteration, we will be simply pushing the value of the root into our queue over here. Now we will start our iteration so that we can go into the deeper level into this binary tree. So for going into the level 1 of our root, what we have to do, we first have to check that whether this queue is empty or not. So since this queue is not empty, what we will do, we will pop this element from the queue. Thus we get the element 1 over here, and now the queue is empty. And as soon as we get the element 1 from our queue, we have to print the element 1 into our output. So over here you can see we have traversed the first node of our element, and that is 1. Now since we are done with the 0th level of our tree, now what we have to do, we have to see whether there exists any children or any child element of this parent root or not. So over here you can see that for the root element 1, we have two children. One is the left node, that is 2, and another is the right node, that is 3. So what we have to do, we again have to push both the element, that is the left side child as well as the right hand side child, into the queue. So let's first understand over here that how I am executing this logic. After that I will be explaining and coding in detail, so that it will be very easy for you to implement the level order traversing. So over here what we are doing, so we are checking that whether there exists any child element for this root 2 or not. So since there are two child elements, that is 2 and 3, we have to push this 2 element over here. And that's it. Right now you can see within our queue we have all the elements that are present on the level 1 of our tree. So over here you can see within this level 1 we have two elements 2 and 3, which is also present into our data structure queue over here. And now since over here we have got the access of both the node of a particular level, what we have to do now, we have to go to our next level, that is the level 2 of our binary tree. So what we have to do, we have to pop this two element from our binary tree, and again we have to push the children of this two node, that is 2 and 3, into our data structure queue. So this is basically a repetitive process which we are doing to traverse each and every level of our binary tree. So let's see what we will be doing over here. So first we will be again popping the element from our queue, and over here we will be pushing the corresponding children of the node 2 over here. So here you can see the children of the node 2 are nothing but 4 and 5. So let's insert the element 4 and 5 here in our queue. So we can get rid of this 2 since we have already popped this element out, and we will pop the next element, that is 3, from here. And again we will check what are the subchildren of this node 3 over here. So here you can see we have the children 6 and 7 within our binary tree. So let's insert the two nodes 6 and 7. And that's it. You can see we have also covered the level 2 of our traversal. And in this way we will be keep on continuing this process. So the way we will be implementing the Java code for the level order traversing is pretty simple and straightforward. So here what I have done, I have created a class called as level order traversal, and within this class I have a simple main block over here. Now let's first define a particular node of a binary tree. So as I have already told you in my previous video, a particular node of our binary tree will consist of three things. Number one is the data part, which means the value of our node, and along with that we will be having two pointers, one for holding that left hand side subtree and another for holding the right hand side subtree. So let's create the two pointer over here, and let's also create a constructor for creating a particular node. I think this is clear to you. So now let's start with the actual implementation of the level order traversal, and for that I will be creating a method called as level order traversal. And within this level order traversal, I will be passing the root element of our binary tree as our parameter. So let's pass the root element as our parameter over here. So let's start with the implementation of the level order traversal, and let's see how easily we can do so. So the first thing that we have to do is we have to check that whether the root element is null or not, which means that over here we are first checking that whether the tree that is getting passed over here for the level order traversal, whether that tree has actually any root or not, which means that if we are passing an empty tree object into our parameter, we should return from here, because since there is no root element, so there is no meaning of traversing an empty binary tree. So that is why we are returning from here. So as we have already told you that for doing a level order traversal of a binary tree, or for doing a breadth first traversal of a tree, we have to consider an additional data structure, and that is a queue data structure. So what we will be doing, we will be declaring a queue over here, and within this queue all the elements that we will be holding within the queue will be of type node. So let's define a queue over here, and as we have discussed for our first case, that is for our 0th index, we will be pushing the first node, that is the root node, into our queue over here. So let's put the root element into our data structure queue. So I think until this it is clear. Now we will start with the iterations so that we can traverse one level at a time. So to do the breadth first traversal over here, we will first check that whether the queue is empty or not. And if the queue is not empty, what we will do, we will pop the element from the queue, which is our current element right now. So let's pop the first element from our queue. And once we get the first element from our queue, we need to print that 0th element as our output, as we have shown it over here. So what we'll do, I will be just printing that into our console. So that is current.data, since we are printing the data of a particular node. Now since we are done with this level, that is the 0th level, now we have to go inside the next level, that is the first level over here. And for that what we are doing, you can see that we are first checking that whether the node which is the current element right now, whether this node have the children element or not. which means that we have to test that whether there exists any left hand side subtree or not. So if there is any left hand subtree that exists over here for this current element, then what we will do, we will push the entire left hand side subtree into the queue. So over here we will be again pushing that element, that is the current dot left hand side subtree, into our queue. Similarly, we will do the same activity for the right hand side subtree. So let's push the right hand side subtree over here. And that's it. This is pretty much what you need for the level order traversing. And over here you can see, with the help of a few lines of code, we have implemented the level order traversal over here. So let's run this code and let's see whether it's actually giving the correct output or not. So let's first define the actual tree into our main block. So for that I have to create an actual tree object into our main block, and then we have to call this level order traversal so that we can test that whether it is working or not. So over here we are done with the two level, that is the parent node and the two children of this node. Now let's define the nodes on the level 2 over here. So here you can see we have created the entire binary tree over here. Now let's call this level order traversal function from here and let's pass the root element over here. So for that I will be making this as a static block, because obviously we cannot call a non-static block from the main block. So let's now call the level order traversal function from here, and we will be passing the root element from here. So let's save it and let's click on run to see whether it's working or not. And great, over here you can see we have got all the output the way we need for the level order traversal. So just for the simplicity of understanding, I will just modify the way it is getting displayed. So let's save it, and bingo, you can see we have got all the nodes displayed in the proper way, the way a level order traversal works for a particular binary tree. So hopefully you guys have thoroughly understand the video of how we have implemented the level order traversal over here, because this is the core concept of how we will be solving the other problem statement that I will be uploading in our upcoming videos. Because in my bucket I have at least 30 to 40 important questions which you must know before appearing for any technical interview on a product-based company. So without wasting much time, let's start with solving one problem at a time, and let's see how we can easily solve those problems with the help of this level order traversal. So see you on our next video. Thank you.